In today's note, we are going to continue with the idea of expanding binomials and look at expanding two special scenarios, or what we call special products. So the first thing we're going to look at is expanding perfect squares. And so again, perfect square is basically anything that's squared or to the power of 2. So what we're going to do first is just kind of do a small investigation. We're going to expand and simplify the following perfect squares, and we're going to see what we get. So again, we can simplify this or expand this to be x plus 3 times x plus 3, and then we can go through and we can FOIL this and come up with a solution. So I'm going to quickly do that. Again, take the time to go through and practice your FOILing or your box method again. But now we have, so this would basically end up with x squared plus 6x plus 9. The next one, if I expand it, again, as two binomials, that's what it looks like. And I'm going to get x squared minus 12x plus 36. Then expanded x squared plus 4x plus 4. So again, take the time to go through, practice your expanding just to make sure. If you're comfortable with it, then again, you can just copy this down. But do try to go through and do the expanding, because that will help with kind of recognizing what the pattern is. And then lastly, I break it up, and then I expand or FOIL or box method. Should get 9x squared minus 6x plus 1. So what we want to do now is, looking back, we want to see, is there a rule or a pattern that for simplifying or expanding these perfect squares, so that I don't have to go through the whole box method or the whole FOIL method. Is there a quicker way that I can do this? And what you're going to be looking at is, you're going to look at kind of basically what you started with and what you ended with, and see, is there a pattern there? Is there some sort of pattern that we can see that carries through all of these? So go back, take a look at all of them, and see, is there some sort of pattern that we can see that does make this, that will make this process a little bit easier. And what we should see when you go through, in either situation, if I have a perfect square, it's roughly going to be the same. The pattern is that the first term of my trinomial or my expanded form is going to be the first term in the bracket squared. Then the second one is going to be, again, the two terms multiplied together and then doubled. And then the last term in my trinomial will be the last term in the bracket squared. If I have a subtraction, it's going to be the exact same thing, except the sign on the second term is going to match that in the binomial. And if we go back and we look at some of our examples that we just did, if I look at 3x minus 1, well, 3x squared is 9x squared. Let me just write it down below. So 3x squared. Negative 6x, the negative comes from the term, but 6 comes from 2 times 3x times 1. And then at the last one, 1 is just 1 squared. And if I go back and do that to all of them, I should see that same pattern. So 2x, let me put brackets around that, 2x squared gives me the 4x squared. 2 times 2x times 5 gives me 20x, and then 5 squared is 25. x squared is x squared. 4 times x, sorry, not, keep the same pattern. So 2 is times 4 times x is 8x. And then 4 squared is 16, and so on. So you can continue this pattern all the way back up, and you would see that this does continue to work out. So that's what our rule or our pattern is. So this is a quicker way that we can use to solve or to expand and simplify. So just some quick steps to squaring or expanding square binomials. Basically, we want to square the first term, multiply the two terms together, and double the product. That would be our second term. Square the second term, or the last term, however you want to refer to it, and keep the sign from the binomial for the second term. So if we want to write out our pattern again, just to kind of see where that is, so the a squared, 2ab, b squared, and then the sign will be based on whatever it is in the binomial. A squared in this case would be minus 2ab plus b squared. So we can see the signs match up. We see our first term. This is our second term in our binomial, and we can see where they end up being. So we can use that to help us with this. So let's go through and use our rule and our pattern to help us quickly expand and simplify our square binomials. And the nice thing with this is if you're not 100% or if you're not very comfortable with this pattern, or you don't recognize the pattern, you can still use the FOIL method to solve. So it's not that you have to use this pattern, it's just a quicker way to do it, and it will be helpful as we move into some later lessons of this unit. It will be helpful for that. But for right now, if you're not that comfortable with the pattern, that's fine, you can still FOIL, although I suggest making sure that you do at least start to recognize the pattern as we go through it. So I'm just going to use the pattern to help us go through and solve this to make it a little bit quicker. So x squared is the first term squared. The second term is going to be 5 times x, and then doubled, or 10x. The sign is going to be positive because that's what it is in the binomial. And then we have 25, or 5 squared. Moving on to the next one, x squared, 8 times x is 8x, doubled is 16x, the minus is the sign because it's the sign in the binomial, and then plus 64 for our last term squared. 3x squared is 9x squared, 3x times 4 is 12x, and then doubled is 24x. Sign is positive, and then 16 is the last term squared. 7c minus 4d all squared, so 7c squared becomes 49c squared. 7c times 4d is 28cd. The sign will be minus because that's what it is in the bracket. And then 4d all squared is 16d squared. So a little bit different when we have variables on both terms in our binomials, but the steps will roughly be the same. We just got to be careful that our middle term has both of those variables. So moving on to e, 2x squared, or all squared, is 4x squared. 2x times 5y is 10xy. Doubled is 20xy. The sign is minus because that's the sign from our binomial. And then 5y all squared is 25y squared. Then lastly, 25x squared. 5x times 3y is 15xy. Doubled is 30xy. Sign is positive because that's what it is from the bracket or the binomial. and then 3y all squared is 9y squared. So let's kind of look at a word example of this. A landscaping company is fixing a client's vegetable garden. The square garden originally had dimensions of 3x minus 4, and they are increasing the dimensions of the garden by 5 meters. Write a simplified expression of the area of the new garden. So, of the new garden, we know that it's going to be 3x minus 4, but because they are increasing it by 5 meters, we're going to plus 5. So that means that the dimensions for a new garden is actually going to be 3x plus 1. Now we want to figure out what is the area. So the area is going to be length times width, or because it's a square, it's just going to be the side length squared, and we know what the side length is. So area is going to equal 3x plus 1 all squared, and we can actually simplify this as, because we're using our pattern, so this becomes 9x squared plus 6x plus 1. So this is actually similar to one of the ones we just did, but this is a simplified expression of the area of the new garden. And if I had a value for x, I could plug that in and find out the actual area. But it just wants an expression for the area, so this is all I have to do. Moving on to our next example. Here what we're going to do is we're going to look at what we call a difference of squares. So it's very similar to a perfect square, except the only difference is that we have the same terms in brackets, except one is plus and one is minus. So here we have x and 3, but one is plus 3 and one is minus 3. So we want to go through, expand them, and simplify the following. So again, you can expand using the FOIL method, right? Because again, we are familiar with that, and that does work regardless of if we recognize the pattern or not. And when we expand that, we should get x squared minus 9. In the next one, we should have 4y squared minus 25. C x squared minus 16, and then 9k squared minus 49. So those are our solutions when we expand and simplify. What we want to do now is check to see again, is there a pattern or is there a rule that will work for simplifying a plus b times a minus b? And will this work for if we switched it around to be a minus b times a plus b? So again, doing the same thing, look at where we started, look at where we end up. Is there a pattern that we can see or a rule that we can see when doing this? And what we should see is that if I have a plus b times a minus b, the result should just be a squared and then minus b squared. So the first term squared minus whatever the second term squared is. And will this work for a minus b times a plus b? Yes, it will, because when we're multiplying, order doesn't matter. So it doesn't matter if I switch them around, it will still be the same thing, as long as I have a difference of squares. So the same two numbers, one's a positive, one's a negative. So the quick steps for this: square the first term. The sign will be minus or negative between the terms, and square the second term. That's all you have to do for expanding a difference of squares. Square the first term, put a minus in, square the second term. And again, if you're not too comfortable with that, or you're not you don't kind of recognize that pattern yet. Again, remember, when you're expanding, you can still use the FOIL method if you want. This is just an easier way to do it, and it will be helpful to recognize this pattern later on. But for right now, if you're not comfortable with that, still stick to the FOIL method. But I would say just make sure that you get, you start to recognize the pattern. So here it'll be x squared minus 4, so x squared, or the first term squared, minus the second term squared. Here it'll be 4x squared minus 1, 9x squared minus 25, 4x squared minus 9y squared, 36m squared minus 49n squared, 9x squared, or sorry, 9x to the power of 4 minus 81. And again, if you were to go through and use the FOIL method, you would see, because there are opposite signs, that's causing us to, that middle term that we've seen before, to basically be canceled out. So that's why we're only left with basically the first and the last numbers squared. So again, this was just looking at expanding some special products, specifically a difference of squares and a perfect squares. If you don't recognize the pattern, again, remember, you can still use the expanding or FOIL method or box method to expand these. This is just a quicker way of expanding, and it will be helpful to recognize these kind of patterns as we get into the later lessons.